Let's continue on with some of these definitions. This next part is kind of an important one, figuring out when sets are equal versus equivalent. So looking down here at this next part. Two sets are equal if they have the exact same elements. So looking up what other problems I've worked before, these two ends are equal. They have the exact same elements. It doesn't matter the order they're in, but they have to look exactly the same. All the same elements have to be in them. Now, that doesn't happen all the time. That's kind of a really special case. We're going to care a little bit more about these equivalent sets. So equivalent sets, two sets are equivalent if they have the same number of elements. And what we can do when they have the same number of elements is we can set up this one-to-one correspondence. So let me give you an example. I'll start off with a fairly easy set. The set, just the numbers 1, 2, and 3. There are 3 elements in that set. And then I'll have another set, and I'll use some math symbols. So we might use division, multiplication, and addition there. These sets are equivalent, but because they both have 3 elements. And we can set up what's called a one-to-one correspondence, where we pair the first item in each list with each other. So in the second with each other and the second with each other. So everybody gets a partner. It's like finding, your field trip partner. Everybody gets one. If everyone has a partner, nobody's left over, then we have this one-to-one correspondence. And what this one-to-one correspondence does is it shows that sets are equivalent. And a one-to-one correspondence is actually how we teach people to count. So we teach our children, our students, to count to 10 just by memorizing the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they memorize those. And then we want them to understand that those words that we're saying go with how many items there are. So we pair a word with an item. Like maybe in our hand we might have a crayon or an M&M or a goldfish. Or even if you think about worksheets when you're in pre-K or kindergarten, where you have like a picture with 5 ladybugs on a leaf. You pair a word, 1 with the first ladybug, 2 with the second ladybug, 3 with the third ladybug. So we call that a one-to-one correspondence. We want the students to set that up, and that's how we teach someone to count, to find a quantity that those items on the page can correspond with the number that we're saying out loud. So I've got an example for us here down below. So I've given us some sets, and we need to figure out which sets are equal and which sets are equivalent. And I want you to actually try this one. I know I haven't worked an example, but I'll go ahead and let you try it. So go ahead and hit pause and give this problem a try. So the ones that are equal have to be exactly the same. So that is B and D. These sets are equal to each other. They both have exactly the same letters of A, B, and C. Equivalent sets just have to have the same number of elements. So any of the sets with 3 elements in them are going to be equivalent. So I could say B is equivalent to C, and that's just our little notation for equivalent. I also could say that B is equivalent to D, and C is equivalent to D. Or I could write it as one big long sentence. All of that information is true. All 3 of those are equivalent. D and B are equivalent. They're also equal. But everything that is equal is also equivalent. Equal is really hard to do. So it's not true the other way. There are plenty of things that are equivalent that are not equal. But if you are equal, you are also equivalent. And kind of going hand in hand with this is the cardinal number. The cardinal number is those number of elements. So up here in this last example, we knew we were looking for anything with 3 elements. So that cardinal number would be 3 for this set. So kind of written out in definition form, that cardinal number is also called the cardinality. It has a symbol. So I'm just going to say for set S, so you could change that out. It might be A or E like I was using before, but that little n means the number of elements in S. The number of elements in S. So I've got an example down here below. We would just count up how many things we see in that set. So there's 1, 2, 3, 4, 5, 6, 7, 8. So the cardinality of S is 8. And our cardinality for our sets up here was 3.